Alrighty, hello everybody. Welcome back to some more Stormworks Build and Rescue. Today we are continuing on with the radar. So today will be video 2 in our radar series, I guess. So I'll show you what I have established. Alright, so here we have the radar. Neat. When it detects me, right, light turns on, tells me how far away I am. I'm assuming this is meters from the radar itself. This is my angle to the radar, which is off the center of the radar. This display doesn't work. I don't know why. I'm assuming it's broken. This is supposed to be the time since the target has been detected. I've never been able to get a signal on it. It is connected to the composite. So I don't know. Anyways, yeah, so that's what I have. And then what I wanted to do was I have placed down a GPS here, and then I have a map to screen. We're going to go over this maybe in this video, maybe in another video. Y is there. X is there. This would essentially follow the player. So what do I need here? I would need a video in. Let's do this real quickly here. Video input. We're gonna go over this. And then in here, this is my video in, and that can go into there, I think. And then we have to edit the Lua script, so that way it doesn't draw this. All right, it's a little quick, I know. Select that. Should be able to just spawn that, and that should show the map, right? No. What's going on here? Oh, I didn't save it. I didn't save it. Alright, I guess I have to do that all over again. Okay. I was just... Oh boy, this is just supposed to be a quick introduction. Okay, so this video should just go into there. Then we go into here. Then we have to get rid of this code here, this is what we're going to do. I'm going to show you all this code, how it works, what to do. Update, there we go. Probably didn't do the update. Then we can take our video and we can put it in through here, and then we can spawn that in, and we should have the... Yes, there's the map there of where we are in the hangar. It's zoomed in, obviously, right? We can zoom out, but it doesn't scale. When it's fully zoomed in, it scales to the map, all right? So our maximum detection on the radar, for whatever reason, in the hangar is 100 meters. If you go beyond 100 meters, you can't be detected by the radar. I don't know if that's because we're in a hangar or what. So in the next tests, I'll have to drag this out there with the vehicle and see if I can extend the field of view. The lowest field of view with the radar is 600 meters. So it should be able to detect me beyond 100, but it doesn't. So that I don't know why. Is it because it's in a hangar? I don't know. Anyways, yeah, so we'll go with that. So we're able to superimpose it over top of the map. It's red. I'm going to change the color of it. Show you how to do that in the code. But yeah, this is what we have. When I'm detected, it shows where I am. Right? The box. The end of the line and where the corner of the box connect, that's the center of me. Right? So the box is just going to be my altitude, probably, and my distance away from wherever I am. But you see, it'll follow me. Whenever I'm detected, it'll follow me. All right, so that's one mode. Okay, so here's the disclaimer. Depending on the radar in Stormworks, depending on your vehicle, will determine the type of radar that you have. Okay, so I'm going to show you how to code in a single target. After that, if you want additional targets, you'll have to code in the additional targets. It really isn't that difficult. You just have to go A, B, C, D, E, and then code it appropriately. And you'll probably need additional Lua blocks because I don't think we'll be able to get all 8 targets into a single Lua block. So we'll have to figure that out, which means we have to make sure, yes, there's 8 channels. Yes, there's 32 number channels. But that's here. If we split that between 1 and 2, we just have to remember that this is maybe 1 to 16 and this is 16 to 32. We just have to remember that when we're writing the code. So that way we're not reading the same numbers on both blocks. Otherwise, if we do that, it's just going to get confused and we're not going to get the results that we want. All right? Yeah, so that's what we have. So the white line the red line is in sync with the white line on the radar. Okay, it spins with the radar, so you'll know when you're being detected. So the only thing that matters is that the arrow on the radar is facing wherever you want your red line. If your red line faces down on the screen, that's the alignment of the radar. And that's all that matters. Now, if you want, so there's like different types of radar. Now, I'm assuming that after I do this really long whole thing about radar, they're going to change it and they're going to make it so that way we can change the radar in the game. Right now you can't. 1, 2, 3, 4, 5. There's 6 modes, okay? We can't change these when we're in the game. The only way to change them is before we set up the radar. All right? So I don't know if eventually the developers are going to change that or not. They might choose to give us another composite, which we can hook up to a panel, which will allow us to change these, right? But right now we can't. So that's why I'm saying we're going to do this whole video series, and then they're probably going to change it, and it'll nullify a lot of what we're doing. But it'll work for now. All right. Yeah, so we have the field of view. Okay, so right now you see our effective range is 600 meters, but for some reason it caps at 100 meters, and I don't know why, so we'll try and change that. The sweep limit, I don't know what that is yet. I haven't really played with it. And then the sweep speed. Oh, sweep limit is, you want it to rotate, or do you want it to rotate 10%, 20%, 30%, up to 50%? So it'll rotate only half. Right now we're rotating basically 360. All right? And then your speed, and then your sweep mode. The sweep mode is, do you want it to spin, or do you want it to pulse back and forth, right? So we could say, okay, I want it to be static, and then it'll just stay right where it is. And we can spawn that in, and then that way the radar doesn't move, and then anything that comes within the field of view, because it's all based on field of view, right? Anything that comes within the field of view of the radar, you see it's detected, and you see we're being written on the screen. Now, I don't know how wide the field of view on the static radar is. It seems to be actually pretty good. Oh, there it is. I found the limit, right? Then you come back in within the field of view. That's not bad. So you could set that up, but as you can see, if you want to cover all cardinal angles, you're going to need 4 of these. One facing this way, one facing that way, one facing that way, one facing this way. You could merge them together and print them all on a single monitor, or you could just have the individual monitors, and when you want to look at that side, just turn it on. I know it seems a little confusing doing it that way, because you have to think a little bit more where the objects you're tracking are. Again, or you can have it sweep, and if it sweeps fast enough, it won't pulse, and it might be able to give you a continuous print. All right? But basically what I'm trying to get at here before we get into the code and stuff is what we're doing right now is we're printing the data on the screen. So every ticket's reading the data, right? If you go outside of the data, it doesn't print it. So if the radar is rotating, every time it blips on you, it's going to print, and every time it doesn't detect you, it won't print. So it can get a little bit annoying, let's say, and it can cause a little bit of lag, versus having an active radar that continuously prints. So what I was trying to do is I'm trying to design an active radar that continuously prints, because for me, I think that's a little bit better than doing it just based on detection, right? It's a little bit harder. Now, where that kind of, where it's going to diverge, okay, is in the design of your vessel. If you're designing a SAR type vessel, your detection is going to be for people and their ship, right? You're on a rescue mission. It's wavy, it's windy, it's dark. You can't see. The people are in the water. You need to find them. So that's what the radar will do. It'll detect up to 8 objects, right? So it'll detect the NPCs in the water. It'll tell you where they are in relation to you. So that's, we're going to go one route with the radar in that direction. And then in the other direction, we'll go with the missiles, the military direction, because you can use one for missiles and all that kind of stuff too. And then ships, vehicles, and aircraft. Now, that was only disclaimer number 1. Disclaimer number 2 is, we'll start a new vehicle while we're waiting on me to finish my spiel here. Disclaimer number 2 is, there's no way for us to set up what the radar detects. So what I mean is, it detects NPCs and it detects vehicles, and you can't choose either or. Now, I don't know if the developers, I could try and request the feature. I don't know if they'll change that or not. Maybe they could see it as a bit of an exploit when it comes to maybe being able to use these for multiplayer, which I guess it could be a bit of an exploit, right? But then you could have, at least if you could set it up without being able to manipulate it in the game, if you could set it up before you spawn the vehicle, then you can, you know, it make more sense with the SAR vehicle. Then you can say, okay, I only want to detect people with the people radar, and I only want to have a vehicle radar. You know, but we can't do that. So yeah, so the radar is kind of limited in that sense, right? So if you're detecting 8 targets, it's 8 targets. People and vehicles. So I don't know how that works. I don't know if, for example, it detects you and then the radar logs you as an active target, and then you go out of range. Does it wipe that active target from its memory? Or do you continue to be target number 1, and when you come back into range, you reappear as target number 1? You know what I mean? Up to 8 targets. Can it track that way? I don't know, because there's no way for us to test that. That's specifically only the developers can give us that information. It's their technology. And then the last part on that would be, yeah, and that's resetting the radar. So I am assuming that if you turn the radar off, it wipes the memory, and then when you turn the radar back on, it starts actively detecting again, and it will find 8 new targets. Right? So that's disclaimer number 2. I'm not sure how that works, and there's no ability for us to code that or program that into our radar that we use. So again, maybe I'll query the devs about it and see whatever. All right, so let's, after all that, how long have I been talking for? Well, 13 minutes. I really apologize. Let's get into it. All right, so the first thing we're going to need is a 3x3 monitor, and you're just going to place that down. Okay, we could take this out of mirror mode. Mirror mode doesn't matter. All right, the next thing we're going to need is the radar. I would point the arrow of the radar facing backwards. You'll see in a minute, once we set it up, our line is going to be facing the bottom of the screen. I think there's a way to change that orientation. I'm pretty sure there is. That's the sine and cosine, I think, is what that is. All right. We need a battery. And now I was using a constant on signal, but in this case, we'll use a toggle button. This is going to be our on-off button. All right, and this button is going, so then we'll connect everything with electricity. Okay, our on-off button turns on the monitor, and it turns on the radar. Okay, now we need a microcontroller. So I have a blank 2x2 that is my go-to. That's what we're going to be using here. If not, create yourself a microcontroller. Make sure it's blank. Make sure it's 2x2. Okay, in the logic, we're going to add, we need a composite. This is going to be composite in from the radar. All right, we need a video. Okay, this is going to be an output. This is going to be our video out to the monitor. Okay. And then the other thing we need, we don't need anything else. That's it for this one. If you want to output a signal, you can add a signal here. Right when the radar detects a signal, it throws a true value into the network, which you can then read. So if you wanted to say, eventually, let's see. Eventually, we're going to color code each target up to 8, right? So each target is going to have its own code, its own color. Then what you could do is you could have a light like this, just an indicator light, and you could have 8 of them. And you could output those as composite, and you could read that composite signal coming off. So every time the radar detects a target, without turning the monitor on, let's say, right? In this case, you have to turn the monitor on, but we could have a relay set up. It would just light up. And then you can say, okay, well, there's a target. Is it worth it? If a bunch of targets light up, maybe it's worth it turning on the radar, right? Something like that. I don't know. I'm just saying that's something you could add to your build, whatever. All right, so let's get into it. So now we need, what do we need inside? Honestly, all we need is a Lua block. That's it. Composite in, video out. Done. Everything goes through the Lua for the radar. So we don't need this. Blank. Okay. First thing we're going to do is we're going to create some variables. We need the width variable. We need a height variable. And we need the A variable. I don't know what the A is for. I can't remember. Anyways. This was based off Mr. N. Jersey. He had done a radar tutorial. And it actually didn't work. And now that I've gone through it, I realize why it didn't work. Anyways, yeah, but now I know. Now we're able to make it work. So, okay. So this, if you're using a 2x2 monitor, change this. A 9x5 monitor, whatever. That's where you have to change these values, okay? It's 3x3 or 96 pixels by 96 pixels. That's a 3x3 monitor. That's the way it is. Then we want our max distance. I don't know if I still use this. I do still use this as a calculation. We'll set that to 100. I still don't know where these two fit into the code. I'm still playing around with it. What I'll do in the future is I'll update the video once I've added some more targets and stuff and played around with this, and I'll be able to provide more detailed information. If you want, you can play around with it, and if you find out what it is, let me know in the comments there. Okay, so I was using the speed, but we're going to get rid of that. And then what we need is the... and we don't need the folder for the targets anymore either. All right, so now we're going to say function, fun, function on tick. Oops, make sure to spell it right. Okay, function on tick. And then what we want to do is we want to say target equals bool, input.get bool. And then this is going to be number 1, right? So this is just target number 1. So if we wanted to say target number 2, we would have to say B, and then input.get bool. And then in here you would have to say 2, because remember we have up to 8 booleans. Boolean is the on-off coming from the radar. So we have up to 8 on-offs, okay? So for now we're only going to do 1. All right, then we need the distance, which we read from the radar. And we also need the angle, which we read from the radar. All right. So distance is going to be input dot get number. And this is going to be number 1. And this is going to be input dot get number, and this will be number 2. We can read up to 4 numbers. Each target gives us 4 numbers that we can read. Let's see, we get the distance, we get the angle, we get the altitude, and then we get the time since detected. time since detected doesn't work. I don't know why. So I write off number 4, but we can get the angle, we can get the altitude if we want to. If we want to add that in here, right? Which I do eventually. So we'll just say here, input dot get, and this is where you can have 2 different types of radar or 3 different types of radar. Now somebody had like a fish finder, so I don't know how this will pick up fish, right? We'll have to take it to the ocean and see. You know what I mean? Like maybe there's before. Okay, so I'm just gonna update that before I get too far into it. Let me read the sonar here. Unless you might need. Okay, so the sonar detects stuff in the water. Cool. So after I do this radar, we'll do sonar next. All right, and then I'll add the sonar to the fishing ship. Oh, that's gonna be really cool because I don't have the sonar. All right, cool. So now that we're back, let's go back here. So we have the altitude. Okay. Then the next thing we need is the speed. That's right, speed. And then this is the rotation number coming off the radar, which is kind of silly. So we want input dot get number. And now this one here, I could have it set to number 4. But I don't want to because number 4 reads off the main composite channel. So what I've done is I've changed it to channel 7. But eventually we're going to have to modify that because if I'm going to be detecting up to 4. All right. Let me slow down a minute. We have 4,000 characters that we can write in a single Lua block. I don't know how many targets we can fit in 4,000 characters. I'm going to assume it's 4, but it might be less than that. It might only be 2, depending on all the information and all the graphics that we want to add to the radar, right? That's why right now it could only be 1, and then maybe we need 8 individual Lua blocks for each individual target, which we could do. We could chain it all together, and we could output it out to a radar, and that's no big deal. We just have to write the code in accordance with that, right? So that's why I'm saying that this series is going to be a little more in depth. We're going to get into a few more videos where I might have to explain how to do all that. Okay, so for now, this is where we're at. So speed, let's go over speed. All right. When you turn the radar on, I'm just going to turn the radar on, and I'm just going to show. To me, this part is kind of silly. It would be a lot easier, but anyhow, the rotation continuously counts up. I don't know why. It should just reset at 1. It should roll over every time it reaches 1. It should roll back over, and then that way we could read it and use that number, but for some reason it doesn't. It just continuously counts up. I tried using a velocity pivot. Velocity pivot does the same thing. The rotation, it just continuously counts forward infinitely. All right, so what I ended up having to do, we need to read that number. All right, so we need to add another number here. It's going to be number input. This is going to be radar rotation. Oops, I said rotation. Radar rotation. All right, and then what we're going to say is that we need a composite. We need to read that. And I'm saying we're going to read this onto channel. Oops, no. Sorry, we need a composite write number. So the number comes in. Start channel. Channel 7 is our channel out. And then we're going to bridge this input through there. All right? That's how that's going to look. We can bridge the main composite channel through this channel, and now we pick up these numbers and we can bring them into the Lua block. So that's how we're able to enhance the system, and we're able to read more things. But you have to try not to get the channels confused, okay? Make sure that you're reading the individual channels. Okay, so now we've got speed. Now we need distance pixel. Now this is our radius, all right? The distance pixel gives us, it tries to scale the distance of the detected object into our radius, which is from the center of the screen to the edge of our circle. So in order to do that, we need to take the distance distance, and we need to divide that by the max distance, and then we need to multiply that by our radius, which in this case is 48, because we're 96 pixels wide. So 48 would be the center of our screen. All right, and then we'll make sure we have this in there. Oh, I gotta change my keyboard over. Like that. All right, perfect. Okay, now we need the A variable. Like I say, I'll have to go back through where I saw the original video just to check to see what he referenced the A variable to. I'm sure he said something about it. So let me go A plus speed, all right? And then we say if A is less than or equal to 0.5, which is basically we're trying to gauge a full rotation, then A equals not 0.5. So I think what this is when the way the game reads a full rotation, it goes from negative 0.5 to 0.5 is 360 degrees, and I think that's what we're trying to measure here. All right, then put the end in there. I think that's what that is. Like I said, I'll have to go back through and figure it out. So then we need angle A-N-G-L-E. Angle A equals, all right, this is our whatever, angle A-N-G-L-E. We want to multiply that by 360. So we turn it into a circle. So now we're reading the azimuth angle. All right, we're turning it into a circle. Then we need to multiply that by, we need to say math.pi. All right, you can't just say pi, it won't just multiply it. And then we want to divide that by 180. It's pretty confusing, huh? And then what that does is that gives us our angle. And it allows us to split it in half so we can use it from our radius. Then we need to say radar A, okay, equals, and then this one here, we're going to have a couple of parentheses. In the first group of parentheses, we're going to say speed, and I had to figure this out. This took me a long time to figure this out. We need to multiply that by 360. So we're basically doing the same thing, and then we need to multiply that by math.pi, right? So we're multiplying it by 3.14, and then we're dividing it by 180. Which is giving us our, now we're able to take our line and we're able to rotate it at the speed of the radar. That's what we're doing here, right? So we're turning it into a circle and then we're turning it into half and we're able to do that. All right, then we need x1, x1, and we need y1, and then we need x2, and we need y2 in that fancy graphic that I put up yesterday in the thumbnail of the azimuth, how to get the x2 and the y2, and you need to divide, and that's your x1 and y1 divided by the distance times sine or cosine, and then you need to multiply that by the azimuth angle, right? So we pretty much already had that figured out in the other code, but I didn't have the azimuth angle. I wasn't reading the azimuth angle, and what I was actually doing was I was just calculating that angle on the screen. So the radar was spinning on its own, regardless of what the actual radar was doing. So whenever the radar detected a object, it would print immediately. So wherever the line was, it would just print the objects so it wouldn't be in orientation or in relation to anything. You understand? And then, so that's why it was printing. And then I realized, well, wait a minute, now it's printing it 3 times. Why is it printing it 3 times? Well, because the radar is spinning fast enough that it's detecting the objects 3 times. And so it's printing 3 times. So it took me a long time to try and figure out, how do I sync the line with the actual radar? Well, you need the azimuth angle, and you need the speed, which is the rotation. And then you need to take the distance and the cosine and sine, and you need to multiply that by the azimuth angle. And that gives us our y2 and our x2. Why does that matter? Because y2 and x2 allows us to draw a line from the center of the screen out to wherever we want. And then if we use this, the azimuth angle, with this math, it allows us to rotate that line 360 degrees. So now we've made a compass, essentially, and we're able to sync that compass to the radar. And so whenever the radar detects an object, we're able to sync that with the screen, and we're able to print that data on the screen. I know it took me a long time to figure that out. I'm sorry if people were saying, why has it taken you a month? Well, that's what I've been doing for a month, amongst other things, trying to figure out how to, orientate in space, right? But that's a story for another day. Okay, so x1. So we need to take the width and divide it by 2. All right, then we need to add 48, which is our radius. Okay, we could have a separate variable up there, which is r, and we could say 48. We could say w2 plus r. But in this case, we're saying 48, right? Then we need plus math. Plus, all right, then we're going to say math.cosine, and this is where we use our cosine. And then we need to take our angle. So we could either use the azimuth angle, but I'm using 1.58, and then plus radar A. Plus radar A. Now radar A, this gives us rotation. So I'm going to be lazy. So let's take this. We're going to copy this because it's identical. We're going to paste that, except in this case, we're going to take the height. So why do we need x1 and why do we need y1? When we're drawing a line, whereas here, draw line, you need x1 and y1 to x2 and y2. So when you're using geometry, I just don't know, let's see here. We'll go to Google and we'll tape up azimuth angle. All right. So when you're doing I'll explain it here. We have x1 and y1. So it says the opposite problem occurs when coordinates x1 and y1 of one point. The distance, the azimuth to another point are known. One can calculate its coordinates, right? So thankfully they've given us the azimuth angle, all right? Because I actually was going to have to figure this out here. I was actually going to do this in the Lua block to get us to this point. And I was like, oh my goodness, I'm actually going to have to. And I started writing that out until I found this part here. And I said, okay. So to get our x2 and our y2, to draw our line from point 1 to point 2, we need this. x1 plus d times sine times the azimuth angle. So fortunately, they give us the azimuth angle. Otherwise, I was going to have to do this myself. All right? So what we need to do is we need to say width divided by 2. All right, then we need to say plus distance pixel. All right, and then we need to multiply that by math.cosine. And we need to say 1.58, which is our angle. And then plus A-N-G-L-E-A, plus our azimuth angle. Okay, and then we need to copy that code. And we need to write it here. And then this section here is going to be our height. All right, so this is the beginning of our line, and this is the end of our line, and this is how we determine it. It's pretty complicated. So now we've made a circle, and now we've made a line going from the center of the circle out to the edge of the circle, right? We've created a radius, and that radius will grow or shrink depending on where the target is in its alignment in a circle. That's pretty, I know, right? It's pretty interesting stuff. All right, then we say end for a game. It's pretty interesting. So then we need function. Now we're going to do the on draw, okay? So now we're actually going to draw this onto a screen. So we need W and we need H. All right, let's see. And this is going to be screen dot get width. Now we could use these variables here. I don't know why I did it this way. It's just the way the code was. Yeah. So I've just finished manipulating this part of the code, and this part of the code I haven't really changed too much. So this is why it still seems kind of like ancient and redundant. I might have a few redundant lines of code that we'll be changing. All right. So when we say screen, oh, this part we don't need. So we just need the if target then, and then what do we want to do if it detects a target, right? So we want to say if target then, because it's going to say bool number 1. We want to say screen dot set color. All right, and then we're going to say 200 0 and what this will do is this is going to change the color of the circle to red, and then we want to say screen dot draw line, and then this is where we needed our x, and then we'll say w divided by 2, h divided by 2, and then we can just say x2 and y2, right? x2 and y2. Or we could just say x1, y1, x2, y2, and we could just reference these. But we don't need to because we're doing that. All right, then we say screen dot draw rectangle. Draw rectangle, and we're going to say x2, y2, and then it's going to be, for now, it's 6 pixels by 6 pixels because I don't quite know. Inside here, this is where we're going to draw the altitude and the distance. So I haven't quite figured that out yet. I just wanted to create the box just so we can see how it is, how big it is on the screen. And that's why I was saying, like, depending on the build that you have, maybe you can only fit a 2x2 monitor in there. So maybe you don't want the rectangle. Maybe you just want a line going to where the target is, right? And that's the only information you want. And that way you can detect multiple targets. You know, so I'm going to have to, we're going to want to be able to manipulate this a little bit depending on the build that you have. Okay? So that's the end of that code. And then we're going to say screen, draw, circle. And then this is going to be the end of this tutorial. The next video I put out, I'll add in additional targets. As you can see, we still have some lines of code. So I think we can comfortably do probably 2, maybe 3 targets. But I do want to put some boxes on the screen. And I do want to add some more information because we're going to be superimposing this over top of the map. So I just want to make sure that I'm able to get all the information where I want it to be, right? So W2, and if I have to have 8 individual blocks, Lua blocks, for each target, so be it. What I'm not doing is I'm not using any bit of the code that's going to slow your game down. I don't put in any functions that ask the code to think or crunch complicated numbers or anything like that, because all that stuff slows the game down. I don't use ghost blocks. I don't use any of that stuff. So, all right, then we say 2 and 48. All right, so that's our circle. This is our radius, and then this is our, I don't know what that is, pixel size or something, I can't remember. Screen draw line, and then this is the line. All right, and then we say W by 2, a height divided by 2, and then we say this is where we need x1 and y1. All right, our x1 and our y1. This is going to tell it. So then the other thing we want to do is we want to set the color of that. Right, so this is going to set the color of the target, and then when it's done, this is going to set the color of the radar. So I don't know, let's look at Google, and then let's look at, was it Lua Color? I think that's right. And then what? I go to the same page. Where is it here? Snippler. And they got all these codes. So I don't know, let's say, oh, I saw yellow there. Where's yellow? Nice and bright, because it's going to be over top of the map. So bright. Where is it? Light yellow. There we go. That's a nice color. Let's copy that. Put that in there. All right. Cool. Oh, no, not cool yet. I need to put an end right there. And then what we do is we'll check it. No errors detected. Doesn't mean there aren't any errors with the code. It just means that so far, so good. Okay, so now what we have is we have our radar. Should be able to turn it on. And the monitor didn't turn on. Just a second. Maybe I don't have my video. So we need the radar rotation comes in. And video goes out to the monitor. And then let's make sure everything turns on. Everything's got power. All right. Spawn it in. Okay, something is going on. Interesting. I suspect it has to do with this. Oh, because I was bringing in the map. But that doesn't matter. Okay, what's going on here? So we have our speed, altitude, angle, and our distance. Let me just make sure I did all the spelling right. Distance. Get number 7 is our rotation. And A plus speed. Input.get. It's where we're getting an error is in the draw. So what did I mess up in the draw here? X1, Y1. X2 and Y2. Oh, draw a circle. See that? I have a 2. It should just be 48. See, there was an error in the code. Yes, there we go. But now it doesn't want to spin. All right. So why is that? Why don't you want to spin, 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 spin? Either that's the speed. But it would give me an error. If I couldn't read the speed value, it would give me an error. Was it speed? Oh, see, I did math.cosine, math.cosine. I didn't change that. I copied and pasted. Should be sine. We have cosine and sine. Those are different. You're two. Duh. All right. All right. All right. Well, that was part of it. That was part of it. See, it wants to spin. Now it's just bouncing back and forth. All right, what's going on now? Make sure I did this right. All right, let's see here. Max distance. Oh, one. We're not using channel 3, so that doesn't matter. Oh boy. Well, I'm definitely W2H2 48 W2H2X1Y1. Yeah, so it's this here. But I don't know if it's oh, I see, because I did it here plus. This should be times. This should be multiply here. All right. This should be multiply here. And then same with this distance pixel, and then that and that and that. All right, let's see if that works. It's a good thing I have the code in front of me that I can reference there. Yeah, there we go. Cool. So now it's active, but it's not detecting me for some reason. Let's see here. I wonder if that's... actually, I'm not too sure. All right, so it's going around. As you can see, it's in sync. It should be detecting me. All right, so the other thing we can do is to see if it's detecting anything is we can say, we can have composite read on off. And this can go out to just a light. This is what I did last time. And then this will be output. And then what we'll do is we'll just connect this here because it's channel 1. Oops. Don't tell me I didn't. No, I didn't save that. Of course not. All right. So this can be output. And then we need a composite. Just like that. We can update that. And then I can take a light. And just to make sure that our radar is working, spawn it. Sometimes it doesn't detect, sometimes it does. Yeah, see, it's not detecting me now. You notice that? The radar is not detecting me. But it says it's active. So now, if I use a constant on signal, so the radar spawns in active, no, it still won't detect me. Oh, I know why. Silly me, silly me, silly me, silly me, silly me. It's because it's trying to detect objects up to like 100,000 kilometers. So I'm insignificant as far as that goes. There we go. It's detecting me now. Oh, what's going on? Hold on. Hold the phone. Let's make sure we have our composite connected. We do not. All right. Let's try that. Let's connect our composite. There we go. Did you see the light turn on? All right, it's detecting me, and then when it detects me, there, I show up on the screen as a little square. Cool. So there it is. There it is. All right. Cool. So thank you very much for watching. There is a basic radar. Now, if you wanted to do a map, I have a map to screen. Honestly, the code is like so easy. There's the code right there if you want it. It even tells you in the help how to make a map to screen. All right. So then you have your X and your Y. Those come in to just set it up just like this. You need a composite right number, channel 1, 2, and 3. Zoom, X, and Y. And zoom comes in from a keypad. X and Y come in from your GPS. All right, and then we can take GPS like this, okay? Make sure it has power. And we can take the X coordinate goes to X, the Y coordinate goes to Y. Zoom you can plug in if you want. We also are going to need a video. This is what you saw me do at the beginning here. We need a video input. All right, and this can say in from map. And just plug that right into the Lua. Come here, take your video, spawn that in. And now when we turn this on, we have a map. Neat, huh? Right? Only the target will be X. It won't affect this target here because we said if target then. And that's what I was saying. So in that section there where we say if target then, this is where you're going to add. If target A then, if target B, C, D, E, this is where you add the colors and what you want, where you want to read any of this information. All right? So yeah, thank you so much for watching, liking, and subscribing. That's going to do it for today's video. Looks like we have lots of room in the code, so we can add, I would say up to four targets comfortably on a single Lua block, because you want to read this and you want to, do some more manipulating. So yeah, that'll do it. That'll do it for today's video. We made radar. So this is part one. Once I add the targets and do a few more things, I will. If you have any questions, leave them in the comments. I'll try to get back to you as soon as I can. Yeah, thank you for liking, watching, and subscribing, and I will see you in the next one. Oops.